we're going to kind of finish up chapter 20 today, and I've picked a problem because you know how I love my M&Ms, love my candy. I really don't actually, which is odd. I gave up. I gave up chips for Lent because I don't care about candy. I don't know. Anyway, I guess that's why I give it all to you, because if it's around, it doesn't bother me. But if you give me a bag of Doritos, I'm in trouble. Okay. Oh, you're better than me. Junk food, right? Anyway, so let's go ahead and talk about this particular problem. I want you to read it and decide why it might be different, the question's worded differently than maybe the one that was just on your quiz. What's different about it? Does it deal with proportions? Okay, so we're still dealing with P. We're still dealing with proportions. Do we have a P hat? Do we have a sample that's been collected? Okay. Do we have a claim? Okay. So we know we're going to be doing a 1 proportion Z test here. But what's different about it? If I was going to set up my hypotheses, what would the null hypothesis be? P equals 0.2. That's the claim. Remember, the claim is always what is the null, right? So in context, that would say the proportion of orange M&Ms is 20%. Okay. What would the alternative be? That's the difference. Huh? You don't know about less than. I don't see any word in there that says less than. Remember how we were talking before the quiz about how do I know what direction to make your alternative hypothesis? And I guess the problem from the one that we did for homework said underrepresented or something like over. I don't remember what word it was. What's the word in here that is tied to the alternative? Contradict. Okay? So I want you to be pulling out the vocabulary words. And the word here that we're trying to prove, or that would be attached to our alternative hypothesis in this case, is the word contradict. The word contradict does not imply greater than nor less than, does it? It just means different from. So when we're talking about something that's different from, it's not what we call a one-tailed test. And everything that we've done, or every example that we've looked at up to this point, has always been in one direction or the other. It's always been greater than or it's been less than. But here we're going to do something called a two-tailed test. And it's a two-tailed test because of that word contradict. I don't know if it's greater or less than. I just know it's not 20. Okay? So it is a two-tailed test. So even though the observed result, and this is kind of important, if we look at 21 out of 122, so if I take 21 divided by 122, our observed statistic, our observed p hat, is definitely less than 20%. That does not mean we're going to say less than, though. We have to be told in words. The vocabulary needs to be there to imply a direction. Okay? We cannot use our sample to imply direction. In other words, we have to make a decision before our sample is even collected, whether we're trying to show that it's greater than, less than, or in this case, not equal to.
So it would be, for the alternative hypothesis, it would be P is not equal to 0.2?
Very good. That's exactly right. Okay? So in this case, let's write what our hypotheses would be. Our null hypothesis is just P equals 0.2. And in context, that would be that 20% of M&Ms are orange. And then our alternative, because we have the word contradict, we're just going to say not equal to 0.2. So the percent of orange M&Ms, by the way, I was looking for context when you did your null and alternative hypotheses on your quiz, so hopefully you did both. A point for the numbers and a point for the actual vocabulary. I'm sorry? What about this sign? This was a point, and this was a point. Okay? All right, so the percent of orange M&Ms is not 20%. And so again, we're not really worrying about a direction here. I don't know if it's greater than, I don't know if it's less than. So let's continue here with our steps. First of all, we skipped step 1. What was step 1? What should you have done? Stated the test. And we kind of said it, but we didn't write it down. What is the name of the test that we're going to be doing here? Well, we don't even have to worry about the two-tailed part. The name of the test is the same. It's still a 1 proportion z-test. Okay? So the name of the test doesn't differ. It's just that we're now going to use it's a two-tailed version of it. Okay? So we've named our test, step 1. And we've stated our hypotheses. Step 2 is going to be to state the conditions. Okay? So let's just kind of go through those conditions. We have 3 of them. Was our sample collected randomly? Oh, I'm not even looking at the problem. Doesn't say. So what would we have to say if we don't know? We're assuming that it's going to be at least a representative sample. Would you agree? Because that's really what a random sample does, isn't it? When we collect a sample randomly assures that it will be as representative as it can be. All right, what's the second condition? You just took a quiz on this. What's the condition? What number is 10%? 21 or 122? 122, the sample size. Okay, so we're going to say that 122 is less than 10% of what? All M&Ms. Yeah. Okay, and then our last one is NP is greater than 10. So N is 20%. So I'm going to say 0.2 times 122. Is that greater than 10? What's 20% of 122? 24.4. Do we have a big enough sample? We do. So, and then we would have 122 times 8, or 0.8. So we'd have NP is greater than 10 and NQ. And so 80% of 122 is just 97.6, which is also greater than 10. So all of our conditions we've checked. We'll move on to step 3 now, which is the test statistic, and you can actually you can start to draw the normal curve if you want to figure out your p-value, which is step 4. But our test, I like to draw the picture because that to me helps me find the z-value. We know that 0.2 is going to go in the middle. Our proportion that we found was 21. Our p-hat was 21 out of 122. So let's go ahead and just write that information down. I'm not sure what that is, if it's even close to anything. So I have to round it, about 0.17. Okay, I'm not going to round it. So, but I'm just going to kind of put it on here so I know where it is. And we're looking at a two-tailed test. So that means that we're going to take this tail and we're going to actually find it over here as well. Okay? And what value would correspond to over here? Well, let's find the z, okay? What z value is associated with 0.17? How do I find that? .17 minus 0.2 over our standard deviation, which we have not found yet. Don't we have a new standard deviation defined? You good, Deja? Remember, it's x minus mu over, or p hat minus p over our standard deviation. Okay? I'll write that on here. P hat minus p over the standard deviation of p hat. That's the formula for the z, the test statistic. So let's find the standard deviation of our test statistic. Actually, it's going to be our claim, which is 0.2 times 0.8 divided by, what's our sample size, 122? Okay, so let's find that there. So square root of, oh, I can do this, hang on. There we go. 0.2 times 0.8 divided by 122. I get 0.036. So the z value on the left-hand side is going to be a negative number, which we expect it to be. So I'm going to have 0.17 minus 0.2 divided by our standard deviation. 0.1, it won't do that. Bummer. Okay.
You forgot to put it at the bottom.
All right. I thought I did. Maybe I didn't. Okay. All right, so 0.17 minus 0.2 divided by, maybe that'll work. There we go. So negative 0.828. Do we expect it to be a negative value? Because it's less than the mean, right? So we expected that, so that makes sense to us. What's the value over here? If it's two-tailed, we think that the symmetric property of the normal curve, so a positive 0.828. I agree. So we have two z values that we're looking at. Okay, so we found our test statistics. That's good. What's step 4? The p-value. Okay, and the p-value, I'm going to be looking here. Now, because I know that the normal curve is symmetric, can't I just find one of the tails and multiply it by 2? I think that's what I'll do. Okay, so I'm going to say 2 times the normal CDF. And I'm just going to find the left-hand tail. It doesn't matter which tail you pick. They're both the same. But I'm going to go from negative E99 to negative 0.828, a mean of 0.2, a standard deviation of 0.036. Why did I multiply it by 2 again? Because it's two-tailed. I just found one tail and multiplied it by 2. That's all. Okay? So when we plug this in here, you can actually plug it in with the 2 there already. It's kind of nice. So we have 2 times the normal CDF of negative E99 to negative 0.828. The mean was 0.2. The standard deviation was 0.036. And we're going to paste it. And ooh, what'd you find? Does that seem right to you? What did I do wrong? Oh! Yes, I'm sorry. You're exactly right. I was going to say, thank you very much. Yeah. I found the test statistic, but here, because I'm not using z, I use the mean and standard deviation. I'm not using z-scores, so I want to be able to put in 0.17. Thank you very much. When you get a 0 value, when you come out with that, that should be a red flag. I mean, that does happen on occasion, but you want to double check yourself, and thank you, Sean. You're exactly right. So let me plug that back in, and it should be positive 0.17, right? And that should be a little bit better. Now, I knew that 0 shouldn't have been there because that z-score is not unusual, is it? If it was an unusual z-score, like a 3, 4, 5, or something like that, then 0 would make sense, or close to it. But I knew that it wasn't unusual, so I knew we'd have a probability here. So in this case, I have a p-value of 0.405. Okay. Is that unusual? Is that a good thing, a bad thing? How do I interpret that? You had to interpret your p-value. What's the interpretation of that? What did you say on your quiz? I even said it before the quiz. Sean, go ahead.
No, for normal CDF, you multiply it by 2.
I'm supposed to. It's two-tailed. Right? Only when it's two-tailed I do that, though, Sean. Okay? What's the interpretation of this? The likelihood that our sample happened by chance is about 40%. Which means, did it happen by chance? Can I reject anything? No. Okay, I have to fail to reject the null. So I really want you to say those words. We're going to fail to reject the null because 0.405 is greater than 0.05. P is greater than alpha. So we can't reject anything, which means in context, what's true? I can't reject that, which means what can we say? We have evidence to suggest that what? 20% of M&Ms are orange. Okay, that's what we're going to say. So that would be the context here. We have evidence to suggest, and this is the evidence, by the way, this whole test, that 20% of M&Ms are orange. Okay? The only thing different about this problem is that we have a two-tailed test because of the word contradict. Everything else stays the same. The alternative hypothesis is now not equal to. We can plug this into the calculator. Let's try that let's double check that we got the same p-value. Where do I go to find the one proportion z test? Stat, tests, and then I believe it is option 5. So we'll plug in. What's that p naught thing, p0? That's the claim. So in this case, it's going to be what? 0.2. X is going to be, in this case, 21 out of a sample size of 122. Notice not equals is an option. Do you see that? We've only been dealing with greater than or less than, but we're doing not equals today. We'll go ahead, and I never showed you the draw option, but I'll show you what that looks like. It just draws the normal curve for you. That's all. And it gives you the z value, which hopefully, ooh, we got a different z value. Something's wrong with our z. Wonder what that was. Did I type everything incorrect? Did y'all get the same thing when you typed it in? Let me just double check. 0.2, 21 out of 122. I'll have to look at that because we should have exactly the same thing. Because it does give you the z and it gives you a p-value. The p-value is even higher than what we got because we got a different z. So something's wrong with our calculations here. I'm not exactly sure what they are, so I'll have to do some research and get back to you on it, okay? But the point is that the p-value is still really high. We would reject the null, etc. But the draw feature is kind of nice, I think. Okay, it gives you more information that you need as well. So let's go back and figure out where we made our mistake. Probably has something to do with the standard deviation, but I'll find it. Yes. What, baby? Is it not the mean? Is what not the mean? Shh. I can't hear you because you're talking like this. That's the mean and the standard deviation. The mean, when we're talking about proportions, is the claim. Okay? All right, I'll look and figure out where we made the mistake. But the point is the two-tailed test was the different thing. Okay? Let me go ahead and assign some problems. I'm going to give you a mixture of two-tailed and one-tailed so you can kind of really pay attention to when to use what. Still in chapter 20. So let's look at that. Okay? So I'm going to give you some problems. We're going to do 13, 14, 19, and 20. Oh, have you already done 20? Yeah, you did 20. So we'll do 19 and 22. Okay, so 4 problems there. They are mostly hypothesis tests. So again, I don't want to give you too many problems to do because they do take a little bit of time. And then we will, next class, move into 2 sample, where we're comparing samples, not just to a claim, but 2 samples to each other. Kind of neat, kind of different.